67, so please number that or go get it if you didn't get it. And so there's one more thing I need to make you aware of about Riemann sums and trapezoidal sums. So this won't take very long, but I need you to be aware of it. And then most of the class today will be to finally give you a good chunk of time to work on your semester exam review, not just the 10 questions that I'd asked you to try to get to last time I saw you, but start to make some real progress there. Okay, and the thing about Riemann and trapezoidal sum estimations that I still need you to know is sometimes they will ask you if a Riemann sum, after you find it, is it an overestimate or an underestimate? So, is your answer bigger than the actual area or smaller than the actual area? So, we're going to look at 4 different scenarios here. Either the function could be increasing or decreasing, or the function could be concave up versus concave down. So, for the first one, let's make a function that looks like he is increasing and concave up. So something like that. Increasing, concave up. And I guess you could memorize all of these, but what I'm hoping that you get out of these 4 examples is that if you make a quick sketch based on its concavity and based on its increasing, decreasing, answering whether it's an underestimate or an overestimate, you can just make a couple quick examples and see. So what I mean by that is if it was a left Riemann sum, you would take the left point and draw it to the right, left point, draw it to the right, left point, draw it to the right. So would a left Riemann sum be an overestimate or underestimate? It would be under, because it's missing some area, missing some more area, missing some more area. It's definitely an underestimate. So whatever answer you get when it is increasing and concave up, a left Riemann sum would be an underestimate. Whereas if it was a right Riemann sum, we would take a point from the right, draw to the left, point to the right, draw to the left, point to the right, draw to the left, and so that would be an overestimate. Again, notice I'm just making stuff up. I'm just giving myself a quick little visual, but too much area plus more too much area plus even more area that's not really there, that's certainly an overestimate. Okay, and this one's the hardest one to see, so as we do the other 3, you probably want to try to make this as big as possible. But if I try to squeeze in some trapezoidal sums, I'll just do 2. Okay, and this one's really close, and this is why it's kind of hard to see, but that is an overestimate.
Does that mean we should try to use the trapezoidal sum more?
You should only use each one of these when you're asked to.
Okay.
You will be told, estimate the area with a left Riemann sum, estimate the area with the midpoint sum, estimate with the right Riemann sum, or estimate with trapezoidal sum. The question will tell you exactly which one it wants.
Thank you.
Okay, so let's go down. Let's keep it increasing, but now let's make it concave down. So again, it helps if you make this a little bit bigger. But a left Riemann sum, I would take a point to the left, draw it to the right, point to the left, draw it to the right, point to the left, draw it to the right. That is certainly under or over? Under. Missing area, missing area, missing area. That's an underestimate. Okay, if it was a right Riemann sum, we'd go from the right to the left, right to left, right to left. Too much area, too much area, too much area. That is certainly an overestimate. And then trapezoidal. Again, it's very close fit. So this is where it helps if your picture is a little bit bigger so that you can see this gap a little bit more. It's close to being exact, but it is still an underestimate. So again, you could memorize all 12 of these things as we're going along here, but I'm hoping that you see, as long as you're considering increasing, decreasing, concave up versus concave down, you can just draw in a couple rectangles from the left if you want to know if your left Riemann sum is overestimate or underestimate, or a couple rectangles from the right, or a couple trapezoids. You should be able to just figure that out in a moment. Okay, over to the right, now I want a decreasing function that is concave up. Okay, let's do one more together, and then I'll have you try the last one to see if you can get it right before we discuss it. So, left Riemann sum, from the left, draw to the right, left draw to the right, left draw to the right. Too much area every single time. The left Riemann sum would be an overestimate. Now notice, that is not the same as over here. Over here, left Riemann sum was an underestimate. It depends on, it's not always going to be over and under, it depends on the function. Okay, right Riemann sum, we should take a point on the function, draw to the left. Take the right side of the rectangle, draw to the left, right to left. Not enough area, not enough area, not enough area. This would be an underestimate. And then trapezoidal. Well, my picture is not looking the best. I think it helps if you make your trapezoids pretty big, because it helps you see. If you make your trapezoids really small, that overestimate area or the underestimate area is going to be so small that you're not going to feel real confident. But now that I made two big trapezoids, I can see it's a little bit too much each time, so that would be an overestimate. Okay, now you try the last possibility. If your graph is decreasing and concave down, try to make a couple quick little sketches and answer those three and see if you get them right. Give everybody another moment to think about this, but if you were finished, you should try to see if there's a pattern that you can notice. When is it an overestimate? When's it an underestimate? Okay, so decreasing, concave down. So decreasing, but concave down, something like that. So left, from left to right, left to right, left to right. Overestimate, it's a little bit too much. Right Riemann sum, from right to left. Right to left, it's an underestimate. And then trapezoidal, again, it might help if you just make one or two big trapezoids to help you see, but that was also an underestimate. You guys okay with those three? Okay, so the shortcut I can teach you or tell you that, again, I don't think you should ever maybe just try to memorize this because you can just figure it out in the moment. But what I want you to get out of this is these are the two things you need to consider. But if your graph is increasing, like the FAR 2, then left Riemann sum is an underestimate, right Riemann sum is an overestimate. If you switch that and make it a decreasing function, then no switch. Left Riemann sum's an overestimate, left Riemann sum's an overestimate, but right Riemann sum becomes an underestimate. So if it is decreasing, left Riemann sums are over, right Riemann sums are over, or under, sorry, and left are over. The concavity only matters for trapezoidal sums. If it is concave up, like these two, that's concave up, the trapezoidal sum will always be an overestimate, and if it's concave down, the trapezoidal sums will always be an underestimate. So the reason why I need you to know this is usually one part of an FRQ, they will ask you to do a left, right, midpoint, well, not a midpoint. They could ask you to do midpoint, but it wouldn't ask you under or overestimate, or trapezoidal. And then they'll follow it up with, is that an overestimate or underestimate, and how do you know? So just to give one quick example here, this was the first FRQ from year 2022, and I cut out most of this, but they gave a table on this question. This was a calculator question, but calculator certainly didn't help with these parts at least. But part B, and we're not going to work this out, but I will tell you the answer if you want to give it a shot. Part B was asking for a right Riemann sum of this. And again, we're going to work with this symbol more next semester, but this part you should be familiar with. This is saying find the area under the curve between 0 and 4. So here's your table, 0 to 4. So you could do a left, right, midpoint, or trapezoidal sum there. This is just going to multiply that answer by 2 pi. But part of why I wanted to put this one on here versus other ones is, you know, a lot of times in this class, you know, we practice the skill quite a bit, but then you also kind of have to be creative and be able to think on the fly. Not because we're trying to be mean to you, but because that's what the AP exam is going to do to you. And for example, this year they threw an R right here. That was the first time they ever put an R there. Teachers had never seen that. Students had never seen that. And to get all the points here, you had to know what was going on with that, or figure out a way to work with that. So if you would like to try that, it's not impossible or anything, but it comes out to 269 pi, but I'm not interested in that. I'm just telling you what it is. But usually they'll ask you to do some sort of Riemann sum, and then maybe on another part they'll say, hey, now is that an overestimate or underestimate, and explain your reasoning. So in this one, notice as R gets bigger, do you see how the values get bigger? So you could say f of R is increasing, and if the function is increasing, is a right Riemann sum an overestimate or an underestimate? It's an overestimate. And the way you could figure that out real quick is you could say, well, I knew it had something to do with increasing, decreasing. I don't know. If it's increasing, from the right, draw to the left, from the right, draw to the left, from the right, draw to the left. You can figure out that it's over an estimate just by making a quick example, but this is your justification. They expect you to say because the function is increasing. That's why it's an overestimate. If it was a trapezoidal sum, you would need to refer to concavity. Because it's concave up or concave down, it's going to be an overestimate or underestimate. So you'd be doing the same things that we did here. So again, I guess you could memorize those 12 things, but realistically, just make sure that those are the things you need to check. You should be able to figure those out in the moment. But just so you know, justification, you need to either refer to the increasing, decreasing, if it's a left or right Riemann sum, or concavity if it was a trapezoidal sum. Okay, any questions about this? This is not something that we get to practice a ton. I would suspect you probably would have a question similar to this sometime second semester, and you will definitely have something like this on your AP exam. But this might be the last time we talk about it together in class. So, okay, then let's find your semester exam review. That 67 you can put away. Oh, also, I forgot to ask for this at the start of class, so I'll give one more quick chance here. 64, I'd asked for in Google Classroom before class today. That was the work assignment from a couple classes ago. So if you did not put that in Google Classroom for whatever reason, I will still give you full credit, but I need it in the basket now. And then I need y'all to get going on your semester exam review. Since I've seen you guys last time, I did post my answers to the FRQs on the website, so you might have to refresh that. Okay, just real quick here before y'all go and work on this. I didn't mention this last time, I don't think, but there's a couple different ways to approach the semester exam review. You can either just start off with question 1, then question 2, then question 3, if you prefer the question types to be mixed up. Or on the front page, a couple years ago, I organized them by topic. So, first topic, being able to use the product rule, the quotient rule, the chain rule, the power rule, or any of the trig identities. If you want to practice a skill at a time, if that one sounds like, I don't know, if that sounds like something you're good at and you want to just knock a bunch of questions out, do questions 19, 20, 21, 22, and 23. And then if they're not working out for you, then that would be a big red flag, especially if those are ones that you felt more confident with. Or vice versa. If you want to try to tackle the ones that you think are going to be more challenging, you can just kind of read through the sample topics, find one, maybe limits is the one you're most worried about, and I tell you which questions are limits, and so you could approach it that way if that's better for you. But there are a couple questions you don't have to worry about. Those are listed on the bottom of the front page. In fact, you don't even need to do them for the homework grade on this. I'm fine with you ignoring those questions, but if you want to try them, they are there. So. Okay, let me give you a little bit of time to work, and I'll get these homeworks put in gradebook, and then I'll come around and help the rest of class.
Algebra 1.
I just gave up.
You clearly can't.
He was the one I asked you.
Just didn't feel like you're not even bad at calculus, you just don't feel like you're and very different from
Where's he going? Where are you?
how did you break it like this? How did you like break it?
So 2.
It's everything I can access is increasing. Below is decreasing. Okay, below is like when it goes like this.
When it's increasing.
Oh, that's yeah, so this is from like 1.5 to like 1.8. Yeah. It's where these are because it's a it's something I remember.
Oh, we just.
Oh yeah. Okay, so yeah, just don't pay
So what did you mark this as? Like,
it's concave one. Yeah, I just did 0.5. Isn't the relative extremes just for zero? That's what you get at max. Oh, you went through.
If it's on that,
I don't know how, but I didn't
it is.
Yeah,
So I know for A that there's no like answer, there's no derivative, but like, because I can't think of how where it would be on the F prime graph. I can't think of like why it is, like what's the reasoning behind it.
Well, to me that looks like a cusp,
what is no?
and you can't take the derivative of a cusp.
Relative extreme.
And what if we're just like going through? What if A was like at that 0 right there?
Okay, well then the derivative would be equal to the slope, and you'd need to do like rise over run. But you would need to know some y values to be able to compute that.
All zeros.
but look at that.
Oh, wait, you're right.
Wait, what? How did that even, how does that get on? What was that replacing? No, but like, how did I get that? Was I erasing my folder or something?
What do you do with that?
I don't know, erasing my folder and see. Okay, function just
Oh, here it is. crazy.
Wait, actually,
Hold on, little bro. I know I'm good, you don't say what you're doing.
also, no,
The vice president.
Grand Elder, 2x, Dumbledore, minus 2x. Oh, that makes sense. So it's like oh, because that's the, what is that? That's the inflation.
on the average.
No. Use words and figure it out.
Oh, we done before, there's a list of questions. Oh, that's what okay, good. Thank God. It's on the-
I didn't mention, but on your semester exam review, the last couple pages are the answers. There are a couple of typos on there. Question 14 is a typo, although you should realize that one's a typo. Question 19 has a typo on the answer. So actually, you might want to write this in on for number 19. You might want to update the answer key.
Second, 19.
19, the answer to 19 is supposed to be
-3. I guess.
that for 19. And number 4 is supposed to be 2x, not negative 2x. But yeah, you might want to change those two on the answer sheet.
14 is supposed to be 12.
Question 4. Wait, okay, never mind. 14. Yes, 14. Sorry, most of this review and answers on the back page are put together long before I was teaching calculus, but if you see any others that you think are a mistake, then of course you're welcome to clarify. Also, quick reminder, as I told you guys last time, we split up our final exam over 2 periods so that you wouldn't feel rushed. So the calculator part will be this time next week. I think it's 6 multiple choice and 1 FRQ. And then the no calculator part will be during your scheduled final exam time, which is on the 13th, which is next Wednesday. And I think it's 9 multiple choice and 1 FRQ.
Any plans for Christmas?
You done with the review? Put that up. Well, then you could have done it at home over the weekend, but you didn't.
Going to cruise maybe? Going to Hawaii?
Good.
Oh, no, I'm asking you if you are.
No.
I'm not going to Hawaii.
Movable is like,
Done with the
it's
review?
discontinuous because there's a hole. Every other type of business movie is not. That's the only one that doesn't count. Infinite discontinuity means that infinity, jump discontinuity, but if it's a hole, then we call it removable.
Okay.
Not hole discontinuity.
Mean value terms is like the change in the rate of change in slope. So it's like y1
trying to squeeze it in.
minus x1 minus y.
Okay, let me try it on my paper and then we'll compare what.
I'm gonna ask one calculator for it. Oh, wait. Because that's one. Yeah, because it has to be. So the relative percentage is going to be equal to 1, right? Because when you try to find this product, it's 0.
It's 2. It's what it's going to. It's not at 1, but what's around 1. So it can be 2 or 3. Oh, we gotta plug into it. No, we don't. From both sides. Oh, it does not exist. No. Does not exist. I think we should ask the answer sheet. There's an answer sheet. It says wrong.
Like you explained.
Watch this.
So that's why the limit is going to be at 5.
Hello?
You see, I see.
I am not. I do. Is it about the Swiss thing? Okay, it got updated. I had checked it again. Yeah, she had school business. It just didn't mark it until recently. I don't know. I didn't see the school business and announcements or anything, but yeah, but she's good. Fine.
Yeah, X is no. Yeah, X goes to X Is number 2 not 0?
It's the same concept.
Oh, wait, number 2 isn't 0. That only works.
Can I just show you that last one?
So what is the difference?
You want to comment on it on your classroom?
Yes, that's good.
Thank you. You want me to resubmit it anyways?
No, I'll get it. Okay, I found there is one more typo on the answer key, so you might want to jot the answer to 25 down. Do you see original?
Yes.
It is right? Okay, I'll have to see how you did it then. I erased all my work, but I tried to work it one algebraic way and it was way too messy. So then I went back and did this, where I made it not have fractions.
Wait, how do you factorize
0. I don't know, man. Oh, you gotta square it.
Well,
So square everything.
don't square it.
One of these is supposed to be squared. I think it might be this Okay, I was wrong. 25 could be that as an answer or the one that's listed. Just kind of depends on which way you choose to work it.
yeah, I don't got that. But it didn't have to do all of it. Because I took out an X and then got 0 and plus or minus the square root.
Wait, so how'd you guys get this?
We're gonna get anything for that one.
Okay.
So
So it sounds like you were talking about when the function equals 0.
Yeah.
Okay. Well, when the function equals 0, those would be X's.
What'd you get for the X?
Or
Oh, you
change
changed?
the line. Yes, it is. It's like this visual, the slope of the group.
It's like you have to furl that. You can change it. No, just change it slowly.
Actually not.
You get 19. Don't worry.
That one isn't right, because that's not an X, so this would just be zero.
I think he's, Mr. Johnson, are you working on something?
Kind of.
Okay, no worries. You're looking busy. I don't know. I didn't want to interrupt you. Actually, I interrupt you all the time.
That'd be a first.
I was about to say, yeah, I do that all the time. I don't know why. I'm a changed man, Mr. Townsend. What's it English?
We don't know. It's just
Yeah, on the number 30, I don't remember which one they intended to be squared. I think it's probably this one. But on our website, I just worked it as it is. Not the answer the way it was. So it's up to you on how you want to try it. I just don't know what they meant for the original question to be. But you can work it the way it's printed and compare it to the video on the website. to make sure you get
Wait, so
On number 5 here.
Oh, it has a minus.
How do we factor that again?
that one doesn't factor in.
Oh.
Not everything factors. Like this one would probably solve with factoring,
Yeah.
but factoring's not the only way to deal with 0 over 0.
How would you?
That's a conjugate. You need to multiply the top and the bottom by 1 plus square root.
Oh, crap.
Oh, so it cancels?
That's the fact that you're next.
How are you doing it?
That's a far time ago.
Wait, you flipped the sign, right?
The middle sign is what makes it conjugate.
So this time,
Whenever you multiply on the top, you have to multiply on the bottom. So
One
it's
into the original negative.
and then multiply the denominators, leave them alone. When you multiply the numerators, it'll FOIL and clean up pretty nicely. Something will cancel, and then you plug in again. You're not gonna have enough space there. You're gonna need a separate sheet of paper.
Yeah, you flip the sign.
Anything formula to my code?
What was the other thing?
oh, so you keep this as the inside symbol.
Did the new cancel the square?
You can't just cancel this with this, because all of this is supposed to be over that support. So what you could do is you could take both of these, have a 1 minus 3x squared, factor it out of the GCF, and then that GCF could then cancel. So it's fine if you divide one term by that, but you have to divide every term by that, not just the one on the right. Of course, today's class period is only going to put a dent in this review work. There's a lot of practice questions on here. But as usual, most of these are worked out on the website. So when you're
56.
working on this outside of class, most of these have some help out there.
I just got negative 3. You got it.
Which one?
Pulls out.
Explain it to us, bud.
I just did it. I just said the bottom.
Is it -2?
Oh, really? How do you know that?
So I got 2x squared over whatever this times that.
It's 2x squared. Wait, that's
The front of it, I can't figure out how to factor the top.
think I'm an idiot?
And
Because it doesn't
zero,
factor.
and the answer is 0 over 0.
Okay.
But 0 can multiply with 5 things.
Right, 0 over 0 will become anything.
That's what
So
I.
the most common way to do is factoring like you did here. But factoring is not the only way to do
Minus
this.
1.
And you multiply.
This is one of the conjugate questions. You need to multiply the top
Oh,
and the bottom by 1
No, you
plus
gotta
the square root
cancel.
of 2x. squared
Oh, we
minus
already
1.
canceled something up. Okay.
Oh, yeah, you can't put it on this one.
Yes. We already canceled.
So it's gonna be 2x over, wait, lucky the math there is conjugate. So, plus, is it minus 1? No, it's minus 1.
Yes, minus 1.
And then you plug it in, this would cancel. That would be 2 minus 1.
Doing okay?
Yeah. Oh, you flip your sign.
Yeah.
Flip this side, not that side.
What?
Do you flip the middle one or the inside?
Yeah, no, you flip the sign, because I got it. Hold up.
Just-
No, I got 1, 2, we did something, it's something for it. Just because you plug in 1, plug in 1, you can negative.
Also, you guys can see there's a handful of small typos in here. A couple on the answer keys, couple on the questions. If you get to any of those in class, of course, you're welcome to ask for clarification. But outside of class, if you get stuck on one that you think has a typo, just use the class video and watch it. And if it is a typo, I will have addressed that in the video. So.
How long is the final time? Like how long? Like how many hours, minutes?
It's normal class period time.
Crap.
Well, actually,
So S.
That's like 2 hours or something. Hour 45.
I don't know. I need to look and see, I guess.
Also, is there going to be as many questions like, or like, is it going to be as long as this?
You can do that in 2 class periods.
We have 6 multiple choice.
6 multiple choice, 1 FRQ the first time, 9 multiple choice, 1 FRQ the second time. We're giving it over 2 periods to make it plenty of time. You have to be prepared sooner, but it will be easier overall because you'll have more time per question.
Wait, factor y, 2x squared minus 1. Factor over negative 1. 2x squared.
You plug it in. Plug 1 in. Then you get 2 minus 1 is 1. Yes, 1 times 1 is 1, times 2 is 2, minus 1 is 1.
I mean, you can't factor it. If you were to factor something, you would just factor that factor at like negative. Okay, There's nothing.
Christian, for your other classes though, it's each final exam is a 90-minute period.
Okay.
So that's normal class time this year. It's like a normal class time for your final exams.
Crap, today's Monday. It's alright. I'll still take my English final. It's fine. Huh? No, the exemption form was today, but I have like 10 missing assignments that I was going to do this weekend before Monday, which was the due date. But today's Monday, which is the due date, so I can't do it.
You also have to have an 80 in the class.
Huh?
You also have to have an 80.
Yeah, but after I get those 10 missing in, it would be easy, like, you know. It's just like, it's like 2 essays that are like 100 points each.
Oh.
And like
What do you do
a bunch of like,
class?
not much really.
You just stand.
We mostly read.
I think the exemption form closed at noon. That's what I was. Huh?
Every class.
For like every class? Oh, crazy.
I believe so. That's what I was told. I don't
What
know.
time is it now? I can't get 4 essays done in negative 20 minutes.
Stop time.
It's 12:23.
Like, the exemption.
They close at 12.
I don't know. I was just told it was closed at 12. It was by a student, so it could be wrong.
Oh,
You can still try it.
well, I can't get all 10 of my assignments in and get back to an 80 before that.
Tired? Just boring.
I actually
The problem is,
No? Well, I know, but you like those.
1 to 5
Wait, no.
Remember, you can't take a derivative at a sharp
I hope I never see you again.
So we still can't go from a positive something to negative something. Yeah, this one's the time that's not.
So, for this part of alphabet, it doesn't equal 0, it just like does it.
Yeah, so this would be on the left.
Right.
So you plug it in up here, that's on the next side of your smaller house, that would be from the left. On the right, you plug it into here, because this is where X is bigger than whatever.
But I thought it didn't equal 0. Because the only point on 0 is 1.
Limits don't have to
There
do
you
with
just
points.
set something
Limits
you
are what
do,
value is it
cancel
approaching
out,
and what value is
The
that.
more I think about it, the more I think
I just remember that these two should be different.
You only cancel one of them.
So make sure you just check your answers.
So
Because
they're
the last
different?
one,
It doesn't exist.
right. If the limit from the left doesn't equal the one on the right, then it does.
No, no, you don't. It's horrible.
Oh, yeah. You told me that.
Yeah. It's this. Listen to it. It's horrible.
I knew y minus y1 and y1 is and y is
I start.
6/3.
Let's make it 3.
My bad.
It's not negative 5.
My bad.
And the limit approaches positive. Wait, isn't this the same exact question? What's the difference between this and this? I can't spot the difference.
It's probably a typo. You probably meant to put nothing there. Like, you know,
Nothing there.
as in like from both sides. So Duke does not.
So there's an underscore.
From both sides. So there's nothing there.
No, it's gonna be this. Because 0 can't be negative or positive. Yeah, so negative 3. Wait, from both sides. Wait, you said them equal?
Why do you attack everyone?
You literally just looked. Are these the same? No. So it does not exist. Let's look at the answer sheet. What question is this? 6. Where's the answer? The limit does not exist. There's a reason you failed this class. Stuff like that. This.
Wait. How do you only, what board is in that? That's like 4. No, those wouldn't. I mean, I guess, but I don't know how you would isolate that. I think you could isolate. Check.
Yeah, like literally just a selection.
But that also means you like do the high
Well, yeah, because I don't like
that would be
to the side.
This would be more irrelevant.
No, if I go to the side, that takes thicker. I'll just do that. I'm not flexing this thing. I can just. These are real good.
Work's gonna be mine. So you guys are gonna turn in those answers?
Okay, you guys still have just under 40 minutes. That's a lot of time to put towards this. You got about 40 minutes. Lots of class time left.
So we're moving this to the next, are we gonna get a day 2?
Super smooth.
Four plates.
4 plates. Last for today?
Or I was kidding.
What are you? value of which is discontinued with is removable. What is that?
I don't know what you just said.
Removable or non-removable?
Oh. Let me look at my notes.
That's a good idea.
How do you know?
How am I gonna find that?
So what did you do that was different? So you just did multiply. Wait, you foiled it, right? Wait, did you foil it or no? That's what you like do like this shit. This and so wait, so you multiply the bottom. What? Yeah, I get it. Because we'll probably like oh, because the negative sign. Because the negative sign. Wait, where would you get that from? Oh, because you back there and the 2 and 3 were so you back there out -2. You back there out -2. Wouldn't it be easier to just factor out -2? -1. That would be easier. I mean, it's just for you to get back the way you do it. Yeah, it would be the same thing. Because it's a negative, and it's just for Are you guys hyped for the push? I'm hyped. I'm so hyped for the push. We're reading like 4 stories, bro. Like, common. Did you guys do common? We're in regionals right now. It's like the marketplace, right? We can do that. Well, if you guys did it, you wouldn't know. You wouldn't know.
I got 7. And I double checked my answer, so I got it right.
The yellow wallpaper, the story of rock what? Oh. The story an hour that the yellow wallpaper, the outcast of Open Glass. Oh yeah, and our final's gonna be on it, and my English teacher is not letting me skip the English final because she decided. Huh? I paid for classes. She decided no, we can't
So the difference between discontinuous and like, how do I know when the denominator equals 0?
Wait, two says, because when you plug into these, would just be zero versus zero. Negative two doesn't equal. Right. What did you say? Oh, okay, yeah, same thing. Zero versus zero is equal. Two. Wait. Oh, this is. It's one and negative one, of course. Oh, that no, C just any constant. Just any constant.
welcome.
What do you love? What's that for?
Can I just cancel that out?
I mean, yeah, I guess. Back When we plugged it back in for it, why is it still Wait, what's that?
X minus 2, X minus 2.
I'm in my concept here.
Because 0 times 0 equals infinity. See, 0 times 0.
Is it because why is it infinity? No, it's infinity when it equals like
It's making 0. Mr. Townsend, hear me out. 0 times 0 equals infinity. That's why this one's infinity.
Well, what's 1 times 3? 13?
3. Because
wait, is it Thompson?
the 3 ate the 1.
Well, maybe the 0 just transposes to 0 and gives you 0.
Now they can't eat each other because they're the same. That's cannibalism. So they conjoin into infinity.
What's 1 times 1?
That's
Say what she said to him. Say what you said to him.
that doesn't work.
Wait, Mr. Thompson, why is this infinity?
I got like some of it, but I got part of it already right, so I took it in.
Okay, so factor the denominator. I'm not sure that you really need to do that anyway, but when you plug in 3 into this, you do direct substitution. You end up with 3 divided by 0. And what happens to a fraction if your numerator is stuck, your denominator keeps getting smaller?
I can retract my earlier statement.
What you can do with a calculator to help you see that, it was 3 over something that goes to 0.
Yeah.
Okay, well obviously you can't put in 0 because that's going to give you an error. But you could put in a number close to 0.
Wow.
See how big that is already? And
Because it's approaching. It's not like that.
That would never be it, but it was.
you can make it a little bit, even a little bit closer to 0. It's going to infinity. So. If your denominator gets bigger, your fraction gets smaller. If your denominator gets smaller, your fraction gets bigger. Because you're dividing it into less pieces.
Yeah, it does.
So why is this one infinity and this one?
Because it's a perimeter. Well, it could be either one. Infinity and negative infinity could be does not exist.
But it always equals, the denominator always equals 0.
What's like
Okay. Does not exist is a more general way to say infinity or negative. Infinity and negative infinity are just ideas, they're not really numbers. So sometimes on the AP exam, if there's multiple choice, sometimes that question might have infinity there and you wouldn't even like it, and sometimes it's gonna have those like this there and something like that. It'll never have both of them. Numbers are interchangeable.
It's an efficiency.
How come it's not negative infinity? If it's
Well, I mean, you can graph it and see. As x approaches 3, the graph's either going up to infinity or down to negative infinity. It can't be doing both.
Find all the vertical asymptotes. Find all the vertical asymptotes.
Guys, one more thought on this real quick. Dividing by this to help you see that as this number gets smaller, the whole thing gets bigger. 0.1 is like 1/10, right? And dividing by 1/10
Just multiplying by 10.
is like multiplying by 10. That's why it gets bigger as your denominator gets smaller.
Yep.
Wait, I have these vertical asymptotes.
Like it.
Okay, I'll be coming around for a few more minutes, so just call me over if you're stuck on talking to too much.
How would we do this?
Yeah.
I accidentally did the last part. This is really frustrating. It's hard to
Really, if you can make a function with it, then it's just a matter of you defining the right naturally. Those are called optimization questions, and don't ask them anymore. So,
Oh, really?
I mean, they are. The thing is, they're pretty easy questions. So I'd like to take time to do them, but since it's not an easy thing, it's not clear.
What?
Wait, is that?
You will. It might be able to.
Oh, it's what do you call it? Motion.
Yeah, I think this one was squared, and they delivered like that, so I'm not sure which one they meant it to be. So I'm not sure, I just want to know what it is, and so you can compare your answers. Or you can put a square there and then hope it matches up with that. I don't know what they intended.
Answer is number 6. Is it? Which ones are bigger than something? Yeah, this one's not supposed to have 4 plus there.
Is there a Y in the thing?
Yeah, so I don't have to do that. Wait,
Why are you close?
just because I don't have to
Check it
prime.
out.
Do I have to do Y prime? That's implicit. This isn't implicit.
Kind of. How would you find this derivative?
Well, yeah, Y prime. Oh.
Wait, it's
But you're really taking the derivative of both sides, and when you take the derivative of y, it's 1 y prime. So you're kind of doing implicit there, but you don't really need to think about it. Whereas if you're taking the derivative and the y is mixed in there, you really need to be thinking about it.
Investing in beautiful data. I don't understand that.
One other suggestion, as you guys find things that you don't remember or question types that you're struggling with, you might want to throw that stuff on a separate sheet of paper, and then the closer you get to the final, you can just focus on that piece of paper and the things that you didn't remember.
Yeah, this, yeah.
Wait, for vertical, just set the bottom to 0, right?
Yeah.
Horizontal is top.
We're on 12. We established 11 is negative 7. 7, 11. Oh my goodness.
What's wrong?
Maybe the universe just has numbers that are like important, and 7, 11 is one of those. Am I wrong?
I think he's on something.
Like, you know, what is it? Avogadro's number?
Who are you talking to?
Just anybody that'll listen to it. Like,
That's the truest thing you've ever said.
Okay, what? Avocado what?
Avogadro. I messed that up. But you know how his number is like, it's like fixed?
I don't know who that is.
What about moles?
That's a chemistry
I don't know.
term.
Yeah, I don't do chemistry.
Or mole, or mile.
I know Euler's number.
0.0 something something.
Or like,
Like 10 to the
Okay, what is
add these constants. They're-
what is the point?
7-11 is an important number.
Okay.
Avogadro's number is
7-11 is two
how
numbers.
many atoms are in a mole.
No. It's like
It's not 7-11.
7 over 11? 711?
7-Elevens?
Yeah.
I think you're going nuts.
The gas station guys, come on. It's important.
I think that's
Because
7
that's the
minus
answer.
11.
2 number 11 is 7.
But you have to
Name
plug it in
yourself.
to make sure they don't don't come back.
You're going nuts. I'm sorry.
And they rhyme.
I know you're joking, but you sound like one of those people who like have numbers all over their wall trying to like figure out something that's not true.
I feel like a conspiracy.
Should there be a negative there
From the
on a
office.
2?
That's number
I
20.
don't
Yeah.
remember every single thing.
Someone with like the billboard and all the lines all over it, just like freaking out.
Two. Down here on this part?
Yes, sir. On the top part. Oh no, is that negative? I don't have my glasses on. Okay.
Well, it's negative here,
Yeah, because when you do
which carries down to there.
What is it?
Well, because you did -2 times negative, so that becomes +2. And then you just drop it to a
Wait.
-3.
So you're saying multiply this negative and then deal with the exponent?
No, I'm saying like multiply the -2 times that
Uh-huh.
negative, and you get +2 from the outside.
Okay, I think what you're saying is multiply this, multiply this negative in.
I just got to that step right there.
Okay. I don't know. Let me work it on my screen for a minute. And then we'll compare. Number 20.
Okay, so each point indicated determine what I almost got it the first one.
Almost. Don't talk.
And then that brand. Wait, who is that, my friend? Which one?
Okay, I'm doing this pretty quick, but is that what your first derivative looks like?
Okay, each point indicated graph related to graduate division.
No, I got -1/2 minus x squared.
Oh, don't hold my hand like that.
Okay. Let me do it again a little bit slower. I probably hadn't.
Oh, it's because you on the plus x it's supposed to be +1. Bottom one is -1.
Okay, so let's see. Derivative of the top with the bottom left alone minus the derivative of the bottom, which would be -1 times the top left alone. Okay, 2 plus x. This is like a +1.
Positive. And that's
Okay, is that what your first derivative looks like?
Yeah.
Okay. Okay, second derivative. Well, honestly, you could do quotient rule, and maybe that's what you did.
Yeah, that's what I did.
I'm gonna just pull this up and make it a -2, just because I think that's easier, but it should be the same. So second derivative, bring the power down, lower the power by 1, and chain rule. So that would give me a -2 in the top and a 2 minus x to the third in the bottom. You got something different there?
Yeah.
Okay, then let me work it your way. So derivative of the top times the bottom left alone minus the top left alone times the derivative of the bottom.
I really want to see.
And you need chain rule right here. So I would say that would be a common error.
Yeah, I did that.
Okay, over the denominator squared. So squared would be to the 4th. This all goes to 0. This would be -2. Okay, do you have something like that?
Yeah, the only difference I had was I got -2. Oh wait, maybe I.
Oh, Jimmy.
Where did that? Oh, okay.
This was supposed to be a minus,
I
but then one of the derivatives was
I
negative. So
didn't include the -1 when multiplying it times 2 minus x squared. I just did the derivative of this without. I put it out, so that made this -2, and that made it positive, so that's why I had ended up with
Oh,
-2.
okay. Yeah.
Crazy.
Yeah. See, my way though, this should still cancel out one of these, and it's still equivalent to that. So
Yeah,
just so you can see, it works out the same way.
Yeah, I have the same thing, except my top 2 is positive.
That's why I think the work on the left's a little easier to not mess up, but
Yeah.
just kind of depends on what the function looks like. Okay guys, y'all still have about 7 minutes, so that's time to work at least one more question hopefully before you pack up. But you can see what I'm asking you to aim for. If I was you, and if I had less than 30 questions finished, by the time I see you on Wednesday, I would say that you were falling behind and you're going to have to play a lot of catch up right before the final, which is not going to work out well. Having 30 questions, any 30 questions done, I would say would be a bare minimum by Wednesday. Do as much as you have time for, but less than 30 should be a red flag that you're not keeping pace. But finish up the question or two that you're on, find a stop in place, and if you need to do a good amount of this for homework, update your planner.